We're moving on to 6.6 now. This video should be a little quicker because the ideas are the same, right? The only difference between the law of sines and the law of cosines is we're using a different formula. But the concept is the same, that what formula do I choose? I use the formula that's only going to leave me with one unknown variable. Now, there are other techniques, right? But I want to keep things to one uniform concept. And we use this for right triangles, law of sines, law of cosines, and for any formula, anything you're solving. The goal and the rule of thumb is to only have one unknown variable in one equation, because that'll allow you to solve for that variable in the equation versus needing multiple equations to do so, creating a system. But again, this is when we're dealing with triangles that are not right triangles. If it's a right triangle, then we'll use our trig ratios to help us solve those triangles. Now, again, I use the capital letters to emphasize the angle, and then it's hard to emphasize capital C, so I put this little vertical line up top. And then, of course, the corresponding sides to those angles. And here are the formulas. Now, one thing you'll notice when we do an example, a clear indicator of why you would choose law of sines over law of cosines, and that's when you don't have a pair of angle and side. Because if you don't have that pair, the corresponding angle and side, then you're always gonna have two unknown variables in the law of sines, and you don't want to create multiple equations to create a system to try to solve for them. And this is where law of cosines is useful. Now, I am gonna write 3 versions of this law of cosines, but truly there's only one. There's truly only one version of the law of cosines. There's not multiple versions. And I'm going to set up this one version 3 different times so you can see how the only thing that's changing is which angle and what side you're choosing. But if you notice, I'm doing everything pretty much the same. And this is where we get our cosine portion. Oh, sorry, not yet. I forgot the minus. And then 2, 2, 2. Here. Now we have our cosine. Cosine, cosine, cosine. Now, the way these work, everything's the same. So you have to choose. You're gonna have these all here represent your sides, and of course what goes inside of a trig function, either a degree or a radian. So it's gonna be an angle, right, since we're dealing with triangles. And these all represent sides. Now the way this works, and this is the main concept, is these two sides, these two parts, these are pairs of each other. So these are pairs. When I say pairs, I'm saying this cosine has the angle And on the other side of the equation, we have the side that corresponds to that angle. And that's going to be true for all of these. So here's the angle, there's a side that corresponds to it. Here's my angle, there's a side that corresponds to it. That's what I'm saying, there's really only one format, but I'm doing this format for each angle. That's why it makes three. Now what happens here, since we already are choosing one side, remember I said these all represent sides. So then these represent the opposing two sides. So if that's side A, there's going to be side B and C. B and C. If we don't have B, then that means we're just left with A and C. A and C. And if we don't have C, then that means it's going to be A and B. A and B. It's just the two opposing sides. So you square, you do the sum of the squares of the two opposing sides, and then you subtract the product of those two opposing sides. You do double that product, and you multiply by the cosine that corresponds to that, the angle that corresponds to that side, if you want to memorize them. But for exams, you're allowed to use these formulas. These I don't expect you to memorize. Well, we will get to the next section, the next couple sections that do involve a lot of formulas, and you are expected to memorize them. But we'll talk about those later. So let's just start our example. Let's jump right into it. So here's our first example. We're going to solve the triangle. So example 1, so we have side A is 2, side B is to 3. I'm only going to do one example because they pretty much are going to all be similar to these. I will give you practice for you to try, but they're all going to be just like this. You're just plugging into a formula. So we have, and again, I just draw a random triangle. I don't, obviously the largest angle should probably have the largest side, but I'm just setting up a triangle. I'm not really putting too much thought into which angle represents. This isn't to scale is what I'm trying to say. I just start plugging angles in. So for example, I'll call this A, B, and then C is 60 degrees. Not for any particular reason, just I went ABC, right? I did the same thing here. I just said ABC. Not being very specific. So angle A. And then we have, A is 2, sorry. B is 3. And we don't know side C. Now, this is where law of sines would not work. Because if you look at each pair of angle and side, we don't have one. So even if I start with sine 60, because I know sine 60, but then I don't know the side that corresponds to it. And the moment I choose any other angle, I will automatically already have two unknown variables, and that's not going to work. Right? The moment if I pick any other ones, I already have one unknown variable. The moment I pick a second one, I'll have my second unknown variable. And I'm not going to be able to do that and that's why I said, for the most part, just pick something and start. And sometimes trying to remember when are you allowed to use one thing versus another, you can sit there for a long time versus just starting and letting the equation show you that it's not working and then move on to another equation. But there are some small nuances, right? I just don't want you to have to memorize for every type of triangle what approach you should take, because it's a lot to memorize. So for right triangles, right, 90-degree angles, we use our trig ratios, right? SOHCAHTOA. Now when it comes to other triangles, I said a quick tip for law of sines would be having an angle, a pair of angles and sides. You want to start there. But the rule of thumb, even for right triangle, for law of sines, law of cosines, is one unknown variable, one equation. For cosines, one unknown, one variable. So I would literally just pick one, right? I would start with C. Let's just start with C. So if we start with C, we square C. And remember, it's going to be equal to the two opposing sides the sum of the two opposing sides squared. So that's going to be 3 squared, or I'll do 2 squared plus 3 squared minus, now I'm going to do I'm going to double the product of these two sides. So that's going to be 2 times 3. And then I'm going to multiply by the cosine of the angle that's corresponding to this side, which the angle that corresponds to it is 60. 60 degrees. Hence, we only have one unknown variable in one equation. You could have picked any other situation, and maybe you have one unknown variable, you might have two. Let's say, for example, I picked 3 and B. So if I did that, I would have 3 squared equals C squared plus 2 squared minus 2 times C, and then cosine of B, because the 3 and B correspond to each other. But now you notice I have I had two unknown variables in that situation. So I would not want to use this one because of the two unknown variables. As long as I only have one unknown variable, that's all what I'm looking for. But here, let's do some of the math here. So we have 4 plus 9 minus 2 times 2 is 4, times 3 is 12. And luckily, cosine of 60 is something we do know. So we remember our angles, right? 1, 2, 3. Cosine pertains to the x-coordinate, so it's the first one. And 60 is up here. But when I say 1, remember I really mean a half. When I say 2, I really mean square root of 2 over 2. When I say 3, I really mean square root of 3 over 2. But this is the one we're looking at, so that is equal to 1/2. And again, every time I bring this up, this 1, 2, 3, I will forever say this portion because I don't want you to leave this class thinking cosine of 60 is equal to 1. It's equal to 1/2, right? So, multiplying this is giving us, right, 4 plus 9 is 13, minus 6 leaves us with 7. And now, of course, this was equal to c squared. All I have to do now is apply our square root property. The square simplify. C is going to be equal to square root of 7. Now, don't forget, you always have to add your plus or minus, but since this is a length, we're talking about it's going to be positive. So our angle is equal to square root of 7. So that's great. Now, technically, if you want to start using the law of, because now I have a pair of angle inside, and I can match that with any other pair inside and have only one unknown variable, the law of sines would work now. But for the practice of using the law of cosines, let's try another one. Let's try to find angle A. So we start with the side that corresponds to A is 2. We square it. Now we have to do the sum of the two opposing sides of 2, and those sides have to be squared. So it's going to be 3 squared plus square root of 7 squared. Now we're going to subtract 2 times, we're doubling the product of those two opposing sides. So 3 and then square root of 7. And then we multiply by the cosine of the angle that corresponds to that side. And the moment you are ever trying to solve for an angle, we have to recall, I'm going to make a quick note here. The moment we have this, we have to remember our cancellation property or our inverse property. Let me zoom in. Right, some people call it cancellation or composition, right? How we can compose two inverses and they simplify to just the argument. So the moment you're looking for an angle, know that that's going to have to be done for these trig functions. Now, to not make this video extremely long, this of course is going to simplify to 4 equals, it's going to be 16, right? Because 3 squared is 9. And square root of 7 squared, square root of 7 squared is 7, 9 plus 7 is 16, and then minus 6 square root of 7 times cosine of angle A, right? And then moving everything over, right? Subtracting over the 16, dividing the negative 6x. That should leave you with, so we skip a couple of algebraic steps, right? We subtract over. This is going to divide. Now notice when we subtract this over, it's going to leave us with a negative, but we're going to divide because here, this definitely means multiplication. Now right here, right, cosine of A, this is composition. A is an argument of cosine. I can't separate these. I can cancel this one using the cancellation property, but I can't divide the cosine out of the A. That's not possible. So if you do that on the exam, you will get an automatic 0 for something like that. So here, I'll just do an extra step showing how you eventually divide things, right? Cosine of A. But this is where you will apply, right? That would leave us with 2 over square root of 7 equals cosine of A, right? And this is where we'll apply our inverse property or cancellation property, which gives me angle A equals cosine inverse of 2 over square root of 7. Now, if you try to approximate 2 over square root of 7, this gives approximately 0.76. Hence, that is definitely in the range, because remember, it's the domain of cosine inverse is from 0 to pi. So this approximation will be 41 degrees. So equals 41 degrees. And if you guys want to practice, try to find angle B using the law of cosines. And because of the sum of the interior angles, you already know what this answer should be. So try to see if you can get that answer by using the law of cosines. But I'll end this here. Now, if you have more questions, message me on Pronto.